Okay, so for today's lesson, we are going to be analyzing the electrons in an atom by illustrating a Bohr model. So we're going to do three things. We're going to identify the maximum number of electrons in each orbit. We're going to be identifying the steps to drawing a Bohr model, and then we're going to be illustrating electrons in an atom using a Bohr model. So we went over this the other day, but just to review again, remember Bohr was one of the scientists in atomic theory who theorized that electrons are located in orbits around the nucleus, okay? And we later came, and now today, call these orbits energy levels or shells, okay? So we refer to these as energy levels or shells. And again, like we went over the other day, when we visualize how electrons are arranged in an atom, we visualize that they are arranged in these shells or energy levels around the nucleus. Now, in these shells or energy levels, okay, that are located around the nucleus, they kind of, each one acts as like a parking lot. So each shell around the nucleus can only fit a maximum number of electrons. And once it's full, that's when it moves to the next shell or next level. So that's how we get more than one shell around a nucleus in an atom, because once a shell is full, the electrons have to move to the next shell. And if that shell becomes full, it has to move to the next one. So it's like a parking lot garage. Each level of the garage can hold a maximum number of cars. So if you enter into the parking garage at level 1 and it's full, you have to move to level 2. If level 2 is full to its maximum capacity, you have to move to level 3, and so on. And that's how these energy levels work, or these orbits work. So level 1, meaning the shell closest to the nucleus, can hold a max of 2 electrons. Level 2, so the second shell, can hold a max of 8 electrons. Level 3, the third shell, can hold a max of 18 electrons. Okay, and we're actually going to stop there. We're not concerned with shell 4 right now because we're not going to be illustrating Bohr models or identifying Bohr models for very large atoms. So we're only going to be concerned with levels 1, 2, and 3. So level 1 can hold a max of 2 electrons, level 2 can hold a maximum of 8 electrons, and level 3 can hold a max of 18 electrons. Okay? So our steps to drawing a Bohr model. Now again, because we are remote, you probably won't have to draw them. On your classwork today, you're going to have to identify the correct one for an element. So it's still important that you know the steps so that you know which correct Bohr model matches to that element. So what we do is we draw the nucleus. We're going to make sure we have the number of neutrons and protons in the nucleus. And then we're going to draw the first energy level. Okay, now we're going to look at the atomic number and draw the electrons in the energy levels according to the rules that determine what are the maximum number of electrons that could fit into each shell. Okay, and then at the end, we're going to make sure our total number of electrons drawn is equal to the total number of electrons for that element. Now, anytime we have to identify or draw a Bohr model, I always find it helpful to get down, hold on, let me move this, sorry. To get down a few pieces of information before you start, okay? So you can see here, we're going to be drawing a Bohr model for carbon and for magnesium, okay? So what's important is to list the number of protons, neutrons, and electrons, and the EC. Okay, I'll put it up here. EC is the electron configuration. That's the number with the hyphens that we learned about the other day. Okay, that's going to be really helpful to us, okay? So let's get the number of protons, neutrons, and electrons. So if you look at carbon on the periodic table, it has an atomic mass of 12, an atomic number of 6, and its EC is 2-4. Okay, so protons, if the atomic number is 6, it has 6 protons, which also means the number of electrons is 6. And neutrons is equal to the atomic mass minus the atomic number. So 12 minus 6 is 6 neutrons. And we said the EC, or the electron configuration, is 2-4. So now that we have all this information, our first step is to put the protons and neutrons inside the nucleus. So in a carbon atom, there are 6 protons in the nucleus and 6 neutrons. Then we're going to draw our first energy level, or our first shell. Okay, now we have a total of 6 electrons we need to draw in. So we're going to start by filling them in. So 1, 2. However, you have to remember the rules. That first shell can only hold a maximum of 2 electrons. So once that reaches 2, now we have to draw the next shell, or energy level. And if we need a total of 6 and we already drew 2 in, we have to put in 4 more. Now, when we learned about electron configuration, we can see that we know that the electron configuration tells us how many shells we have and how many electrons are located in each shell. So the easiest way to draw a Bohr model is to always use the electron configuration. It tells us that there are 2 electrons in the first shell and then 4 located in the second. Okay, and then again, always count up that you have a total of 6 electrons. 1, 2, 3, 4, 5, 6. And we have our 6 electrons there accounted for. Okay, let's do it for magnesium. So magnesium has an atomic number of 12. So therefore, it has 12 protons and 12 electrons. And it has an atomic mass of 24. So the neutrons would be 24 minus 12, which is also 12. So we can have 24 protons. I'm sorry, not 24. 12 protons and 12 neutrons in the nucleus. Okay. Now, we're also going to jot down the electron configuration. The electron configuration of magnesium is 2-8-2. Okay. So what we're going to do is draw the first energy level and make sure we follow the rules, okay? And we can also refer to our electron configuration. So if we're following the rules, the rule is that the first shell can only hold a max of 2 electrons. So I'm going to fill in 1, 2. That's full. Once it's full, you have to draw the next shell. Now, we can also look at the electron configuration. It's telling me that in the first shell, there's 2 electrons. In the second shell, there are 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, and again, level 2 or shell 2 can only hold a maximum of 8 electrons. So once we get to 8 here, we have to move to the next one. And the electron configuration is telling us that the third shell has 2 electrons in it, right? So if we had to draw 12 electrons in total. So we have 2 in the first, then 8 in the second, that makes 10, and then the remaining 2 in the third. And that would be the correct Bohr model. So for your classwork today, it's going to be multiple choice questions where you have to identify the correct Bohr model for that element. So there's several ways you can do that. You can look to make sure it has the correct number of electrons and the correct number of protons. You can check the electron configuration and then try and match it to that element. Okay, we are going to do one question together. So once you're done watching this video, we'll regroup, we'll do a classwork together, and you'll do the remaining on your own.